worry about nitrogen pollution, because if nitrogen is 78% of our atmosphere as N2, what is the problem? Of course, nitrogen is unreactive in that form, but through our human activities, we've converted it into what we call reactive nitrogen forms. That's nitrogen and hydrogen, ammonia, and nitrogen, oxygen, nitrates, and lots of other forms. So an amino acid is a carbon chain with nitrogen and two hydrogens. Proteins take that on board, and so we end up with nitrogen being the stuff of life. DNA is a nitrogen molecule. All the enzymes in our bodies are nitrogen molecules. So if carbon is the structure of life, then nitrogen is what is giving us diversity in life. How many nitrogen molecules are on the planet? It's impossible to answer because every DNA molecule is a different nitrogen compound. So billions, billions, billions of different nitrogen compounds. Now, the problem is, in our human endeavor to make those nitrogen compounds, we're extremely wasteful. That means that when we are turning atmospheric nitrogen into fertilizers, for example, in the Haber-Bosch process, and then using those fertilizers to grow food, feeding ourselves, but also feeding livestock and then eating the livestock. That means we have a very wasteful system with roughly 80% of that nitrogen resource being wasted. Only 20% ends up being used perfectly. So it means we have a problem with nitrogen pollution. We have a problem with low efficiency. Now, if we compare nitrogen and carbon, carbon is really, as we know, a climate issue. Carbon dioxide and methane as well, both climate warming gases. But nitrogen is multiple dimensions. It's contributing to water pollution as nitrate in water and organic nitrogen compounds. It's contributing to air pollution as fine particulate matter and affecting ecosystems. It's affecting greenhouse gas balance with the nitrous oxide, that's laughing gas emissions. In terms of ecosystems, it's affecting forests, affecting freshwaters. All ecosystems are affected by nitrogen. Probably somewhere on the planet there might be something really clean, which is not much affected, but many places across the planet affected. And of course, it's mediated through changes in soils as well, as changing nitrogen. Too much nitrogen affects soil quality. Too little nitrogen in agricultural soils, if we take out more than we put in, then we have a problem. Now, in terms of that waste of resources, it's also an economic waste of money. So if we take the total value of nitrogen wasted to air and water, we get about 200 million tons. If we multiply that by $1.5 per kilogram nitrogen, we get about 600 billion dollars worth of nitrogen wasted resource. Now, in the Colombo Declaration, which was agreed in your city in 2019, governments made an agreement to have the ambition to halve nitrogen waste by 2030. That would be effectively, at today's prices, saving around 300 billion US dollars a year worth of resources. So why don't we do it? Why not take this obvious action? And I think it's back to this fragmentation of issues where nitrogen is a little part of everybody's problem, but we don't necessarily see the big picture. So we need to make it more visible. We need events like this to raise awareness of the importance of nitrogen pollution in its many dimensions if everybody's going to be motivated to act. So I want to come on now to talk about one form of nitrogen pollution which we've been studying at the Dilmah Climate Change Research Centre at Rilagala Forest, and that is ammonia. Ammonia is one nitrogen and three hydrogens, NH3. It's an alkali, and it's a basis form of nutrients, so amino acids, amines, etc. So with ammonia and ammonium, that's with 4 hydrogens, in your soil, then plants can grow and make nutrients. But the question is, how much? Too much, too little? If it's too much, we then affect sensitive biodiversity that's vulnerable to that too much ammonia. And not to forget, the ammonia is having other effects forming fine particulate matter in the atmosphere. So ammonia is an alkali, together with nitric acid and sulfur dioxide in the atmosphere, forming salts, ammonium sulfate, ammonium nitrate. And with other parts of particulate matter, those get deep inside our airways, shortening lives. Now, we, as I think you will have heard from Professor Nissanka, have been taking part in this South Asian Nitrogen Hub, all 8 countries across South Asia. That means we've been looking at nitrogen in policies, nitrogen in solutions, in agronomic solutions, and in industrial solutions. We've been looking to raise awareness by studying key threats, and we've been studying the flows. Now, when it came to studying those key threats, we selected 2 systems, the forests and the coral reefs. And why do that? Basically because South Asia is a hotspot of nitrogen pollution, and we think that both of those ecosystems are understudied. And there's a parallel between those, particularly with the lichens as indicators of air pollution growing on the forests. Now, perhaps you can just about see the tree behind me. The light isn't very good, but on that tree trunk are really happily growing lichens. And I'm in a clean part of Scotland with a rich biodiversity of lichens on the forests. It's an indicator of good tree health. But if I went to a more agricultural part of Scotland, then those lichens would be different. We'd see the fingerprint of air pollution having its effects. Now, if we compare the study that's been going on in Scotland, there's much more data on air quality and lichens in Scotland. And so our South Asian Nitrogen Hub has been bringing new evidence forward to try to understand that. With 2 parts. The first part is looking at lichens in the Himalayan zone, the sub-Himalayan forests, with the Indo-Gangetic Plain being a real hotspot of nitrogen pollution. The trees are standing with their feet in nitrogen air pollution, and we expect with substantial effects. So we've been looking at the distribution of ammonia, the distributions of lichens. We're currently putting those data sets together to understand the scale of that impact. But we also wanted to look experimentally, and we looked long and hard to find a site suitable for doing those experimental studies. And I'm very happy to say that with the introduction from Gauthami from the Natural History Museum, who's together with you today at Dilmah, we found a great site in the Dilmah Climate Change Research Centre. Without your endeavours there in establishing that centre high up on the top of the hill, it simply wouldn't be possible to do this experiment. So we had expected to do it in the sub-Himalayan zone. We found ourselves doing it in the Sri Lankan highlands. We're very happy to be there. So that experiment is proceeding. I think others after me, Ajinkya, Boudica, Maud and others will tell you more about how that experiment is getting on and the results we're seeing from it. But what I can tell you is that this is critical evidence for us, already showing that the lichens are sensitive to ammonia pollution in Sri Lanka, just as they are in the Himalayan zone, just as they are in the UK, and that this is a key signal for biodiversity change if we're worried about our natural habitats. And remember, that is let's say, a litmus test of change. It's because when you see the lichens changing, the whole ecosystem function is changing. There'll be changes in soils, emissions of greenhouse gases, water quality issues, the whole nitrogen cycle being changed. So this is a really important test. So let's come on then to talk about solutions. I understand that Professor Nissanka will have told you some of his favourites. The point I want to make here about solutions is that there's an opportunity, particularly in agriculture, to farm better. And we're really happy to be working with you in Dilmah on this, and look further forward to building our conversations on how, for example, fertilizer use in Sri Lanka can be optimized more effectively. Now, a few years ago, you will know that a former president banned fertilizers in Sri Lanka. At the same time, in another policies realm, I was working with the Ministry of Environment of Sri Lanka, we put forward a resolution to the United Nations Environment Assembly building on the Colombo Declaration. And that was not proposing to ban fertilizers. It was rather saying to halve that nitrogen waste. And what we mean is, if you halve those losses to air, land, and water, more is going to be available for your crop. So no target to reduce fertilizer inputs, but rather a target to reduce the losses. And when reducing the losses, then of course, there's an opportunity to save on the inputs because not so much fertilizer will be needed. A more efficient system saves money and good for the environment. So that points towards not only those methods we need, for example, fertilizer deep placement or urease inhibitors or nitrification inhibitors, different timing, but it also points towards need to measure the system to find ways of cheap sampling of soil quality so that farmers can have more confidence that they don't need to apply excessive fertilizer use. So good for the pocket, good for the environment. And I think here, this is an opportunity for Dilmah to play another leading role in the future, sharing with others across Sri Lanka, not just in the forest site, but in terms of rolling out and demonstrating those good agricultural practices. So I think I've come to the end of the time here, and I just want to wish you well as you meet and discuss. It's a pleasure to be working with you with Dilmah. As I say, without you, we couldn't do it. Thank you, Rishan, for hosting us. Thank you, Ashan, for managing the call. And I look forward to speaking with you in person further when I'm next in Sri Lanka. Thank you.